from the internet. Now do it right. That'd be great. So you inherited an old police radio from your Uncle Frank, the old police dispatcher from 1 Adam 12 back in the day, right? In this case, it's an FM communications receiver made by Lafayette, the model HA-52. So what do you do with this thing? Because there's nothing to listen to on those bands. Well, let D-Lab show you a great use for that old radio. Why don't we repurpose it into a guitar amp? So here it is, the Lafayette model HA-52A FM communications receiver. Now you know from some of my past videos that I've taken the model HA-520 and converted those into push-pull 6AQ5 little guitar amp heads, right? And it really turns out slick. This cabinet, however, is a little bit smaller and it is missing one control that the 520 has, right? But it's still a good candidate to turn into a very cool little boutique amp. Let's pull the top, flip her around, see what we're dealing with. All right, we got the top popped, all right? There she is. A little grimy, a little dusty and dirty from over the years. There's the internal speaker, which we can't use because it's not going to be able to handle the power of a guitar amp. But what the crown jewel is on these old receivers is this power transformer, right? So it was kind of oversized for what it was actually doing in the little receiver. And right here, I believe, should be the output tube, which is a 6AR5. Interesting, I have not used that tube in the past. And this right here is probably a 12AX7 that drives it. Let me see. Yep, the 12AX7A RCA. If that thing's any good, that'd be super cool. Filter cap is obviously dried up and worthless, and all this stuff needs to leave to give us the real estate for a guitar amp. Get the bottom panel off. See, we have a little bit of corrosion action there, but that'll clean right up. The rest of the chassis looks good. There is the original output transformer for that 6AR5 output tube. Okay, we're not going to use that, but what I'm interested in, I don't care about any of this stuff because it's going to go bye-bye, but what I'm very interested in is the rating of this power transformer. So let me clip this stuff out of the way and we'll see if that transformer can be used for, say, a 5-watt 6V6 Class A amp. I've cut everything out of the way so we can see the terminals of the power transformer. Now over here you see our primary side. You got 0, which is your neutral, the 100 volt tap, which is not used, and the 117 volt tap, which was used back in the day. So obviously our line voltage these days is around 123 volts, which isn't going to hurt anything. The transformer will just put out a little more voltage on the secondaries, right? Now here is our filament circuit. 3 amp at 6.3 volts for the tubes. And then over here is our high voltage. Now you can see they only have 2 terminals. 160 volt 160, and it says 85 milliamps DC. Well, if there's not a center tap, we can't do our conventional 2 diode type of rectification. So you'd actually have to do a full wave rectification, right? So I need to see if any of these other terminals may be a center tap. But even if they are, and I came out with the 160 and rectified that, we'd be lucky to get 200 volts out of this transformer, and that's really not enough to drive a 6V6 Class A type tube to any kind of a power rating, right? So in other words, we're going to have to do something different. So I'm going to verify that. And then the other note is, this transformer was actually made by a company called Trio, and they're out of Japan. They also made radios for like Allied, Realistic, Kenwood, and several others. So this is a very nice transformer, and I really hope to use it for this retrofit. Alright, so I've got the AC line cord cut and isolated, and I'm getting ready to apply the 120 to this transformer so we can check the outputs. But I was reviewing that last clip, and I was like, man, there's something odd here on the transformer. So if you look right down here, right under those terminals, do you see what I see? There is actually a straight pin down here. I don't know what's holding it, but there it, whoops, I dropped it. Figures. Anyway, I'll retrieve that straight pin, but it was actually going from this terminal, it says 160 volts, and it was kind of going down here really close to the filament line. So I'm hoping that somebody in the past didn't turn that on and short it out, or this transformer's history. Anyway, let me get that pin out, and then we're going to fire this thing up using a variac and see if the transformer is okay. Here's that straight pin that was lodged across the terminals on the power transformer. Good thing that's out of there, right? Could have had a fireworks show for you guys. Alright, I've got the transformer only connected to my variac, and right now we're going to look at the filament circuit. I'm not going to bring it up full voltage, but I'm just going to bring it up enough to verify that I have voltage. So right now we know the filament circuit's good, right? Now let's see if that 160 line is good, which is the high voltage. You can see we already have a little voltage showing up, even with the variac all the way down. So that's a good sign. Here we go. Oh yeah, lots of voltage. Alright, so let's go to the 1000 volt scale, because that says 160 and 160. So maybe it will actually give us over 300 volts. So right there is about 120 input, and look at there, 326 volts. So that's very cool. What we're going to end up doing now, since we actually have 300 and something volts versus what I thought was only 160, we're going to full wave rectify that, throw some capacitators on it, and we'll have plenty of voltage to drive a Class A 6V6 amp. Back to the question, did the high voltage side, the 160 actually have a center tap lead on it? The answer to that is yes. So I'm bringing up my variac again. In this case, my meter, one side is hooked to chassis, one side is hooked to one of the 160 volt taps. So if you look, there's about 120 input, got about 160 something volts, right? From ground to one side of the high voltage, which tells me that yeah, there is a center tap on that transformer. But we are not going to use that, because if I did and I rectified and threw some capacitators on this, I would only end up with a little over 200 volts, which is not enough to drive that 6V6 tube Class A. It wouldn't put out crap for wattage. So we're going to go back to the full wave rectifier, and we'll utilize that 300 and something volts you saw earlier. So after I rectify that, we're going to be up close to 400 volts, which is more like it. So in case you're wondering which one of these leads was the center tap for the high voltage, well, I can show you. So if we go from here to here, there's about 186 ohms across the high voltage winding. But if you take one of those and go to this terminal that says EB, you'll see 90 ohms from that side and 95 ohms or so from that side. So EB was the original center tap for the high voltage windings. We're not going to use that. Now that I've determined that I can use this power transformer, everything else in here has to leave. So I'm going to pretty much gut out everything that you see except for that power transformer. Nothing else in this thing is of value. Same thing on the top side. We're going to go through here and everything leaves. This speaker, tuning caps, tubes, IF cans, the whole bit. So we're going to get all this cleared out and have us a new footprint for the new Class A circuit. Before I go too far, I wanted to point out, remember I said this thing was made by Trio. We'll take a look here on the back of the main tuning cap. There it is, Trio. And here is the original inspection tag dated 1966. I'm going to leave that intact. Everything back here should stay about the same, except we're going to add a jack for a speaker. So I'll make sure to put that in a position that we don't interfere with that bit of nostalgia that's left. Okay, And I know a lot of you may not like the idea that I repurpose this stuff, but if you had this radio, would you take the time to restore it and then listen to a band that has absolutely no activity on it? That's why I do it.
Yeah. Yeah.
Oh boy.
Yeah.
Stick from the internet. Slid in the back door of D-Lab again.
Yeah.
Here to spread some joy.
Yeah.
What's happening,
Yeah.
Dick? Yeah. Defacing some more history, I see, D-Lab. Nope. Repurposing this radio to save it from the dump.
Yeah.
Well, how about you turn your empty wine bottles into candle holders? Oh, yeah. You just pitched them. No value to you.
Yeah.
Okay, Dick. Looks like the troll gin got by my firewall again. It's time for you to exit.
Hello, Peter. What's happening? Hello, Peter. What's happening?
So, Peter, what's happening?
Okay. 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 Okay.
Yeah, so that's where you'll end up if you're a DFI at D-Lab.
Yeah.
Yeah, hi, it's Bill Lumberg again. I just wanted to make sure you knew that...
Alright, my scrap out effort's coming along nicely. Okay, got a lot of that old stuff cleared out. There's two things I wanted to bring up. One, this old radio never had a power fuse. There's plenty of room in here to add one, and obviously you're going to want to do that. Secondly, this is the old output transformer. If you wanted to reuse this, you can. It's actually a 5K primary, and then the secondary, you can see the yellow wire, but there's also a green one tucked way down there that they clipped off. So you could reattach and have the option of 4 or 8 ohms for your little Class A amp. The only issue is I don't know what the power rating was of this little guy. It looks to be about a 3 to 4 watter, so you could try it. And if it doesn't go in a ball of smoke, you just saved yourself probably 30 bucks for an output transformer. So the knobs here, as you can see, are pretty dirty and corroded. This one is froze right up, won't move. I tried to get the set screws out of these two and they won't budge. So I'm probably going to have to destroy the knobs to get them out. But I'm going to have to drill these things. Hate to do it, but that's the way it goes. The other thing is this inner platform here where the tuning cap was mounted on top. I need that out of here, and they soldered it. You can see nice big globs of grounding solder, right? So I'm going to have to heat that up and push that panel out. We'll do that with a big old Unger. So there it is, the old Unger that my dad used back in the day to solder slot car chassis. I use it all the time. I'd highly suggest if you're going to work on these big old tube amps and you got to heat up a large area of metal, get yourself one of these. I mean, look at that. It's about 1,000-degree tip. Makes easy work out of that. So yep, had to drill them all out to get the knobs off. They were just frozen on the shafts. And this is another reason why you can see it probably would not be worth trying to restore something like this. But we're going to give it a new life. Well, here's what I'm envisioning for the little Class A 6v6 Lafayette retrofit. We have our power supply section over here, new power supply cap. The power switch will be down there where you saw that headphone jack. Alright, this section here, I'm going to put in a little aluminum plate for that tuning cap area that I removed. So the 6v6 will sit about here, 12AX7 over here. Here's our output transformer, and this has taps for 4 and 8 ohms, so we'll add some jacks down there for that. So here's the front view. Like I said, the power supply section is over here, so our power switch is going to be here. We still have our volume control, but we're going to add treble and bass, and then in this area I'll add the input jack for the guitar. We're going to maintain this glass window, and I'll probably put some cool blue lighting behind this old grill, just like my other HA-52A series that I did. Alright, so I've made a decision on where I'm going to put the input jack. I really want this thing to look symmetrical. So here was where the old phono jack was. And I want to do the same thing on that corner for the input jack and make this the power switch because it's right by the power supply, right? So if you take a look at what they did to have access, they actually notched out the chassis right there so that the original plug that was in there could fit in and have clearance for the terminals, because if you look at the cabinet, it has spacers, so the cabinet does not fit up tight to the chassis. So I'm going to do the same thing over here for my input jack. So it's going to go right in this area. I'm going to open that up to allow the same clearance. I've already measured the front panel to get the same dimension where that hole is. So they'll be nice and symmetrical. Alright, so what I need to do is make the same cutout over on the other side of the amp. I've etched a couple little lines here where I'm going to do the cutout, and that will allow the clearance for the new audio input jack that's going to go here. The other thing I wanted to let you guys know about is when I took out those old pots, there was a lot of corrosion between this chassis and the front panel, so I actually had to cut the nuts right off of the old pots. They were just solidified, and the reason is, here's the aluminum front panel, right? And then behind it is a steel chassis. Well, you have interaction between those two materials, which causes corrosion, and that corrosion got into everything. So before I reassemble this, I'm obviously going to sand off this corrosion, and I'm going to put some primer paint in this area to stop that from happening again. That way the next guy, say 50 years from now, that wants to turn this into something else won't have to deal with that. Isn't that great? So there we go. A little magic with the Dremel tool. Have the new access here. The audio jack will go in with no interference to the chassis, just like on the other side. So to fill that rectangular hole where the old tuning cap was, and to give me a support for my 6v6 tube, I found this nice piece of brass. So I've already pre-tinned the areas. We're just going to drop them in place. Use my big old unger. Heat it up. I'm just going to let the solder do the mounting because there's not much stress on it. We'll get the tube mounted, and this will also be nice since we won't have that difference of materials. You know, sometimes I use a piece of aluminum and I pop rivet it, and that would cause the same issue, right? So we'll go with brass. So we got this side tack soldered on the top, so now I'm going to go underneath where the original solder blobs were that held the other plate. We'll just reuse that. And I get the hole punched for the 6v6. Look how nice that unger works. Tell you what, you can't beat these old monsters. So I've got all the mechanical things mounted up. Here's our power switch. This will be volume, treble, bass. This is a new input jack that required a slight modification for it to install. Backside, this is my output transformer, 6v6, 12AX7. The rectifiers are obviously going to be solid state. Here's a new filter cap, fuse holder. I need to add the two speaker jacks for 4 and 8 ohms, but we're getting close. Here we are top side. I want to focus on the power supply section. Since I have that wired up, I want to check that first to see what kind of voltage we're dealing with after it's filtered, rectified, etc. So here's our main power transformer. We have a dual 50 microfarad cap here at 500 volts, and here is a 4 Henry choke. I'm going to flip this thing upside down and I'll show you the wiring and then we'll go into the initial power supply test. Alright, here we are bottom side. The blue wires are the filament supply, which has a couple 100 ohm resistors for that ground balancing. And right now it's only wired to the 6V6, but we're not testing that right now. Here's the high voltage lines, those 260 volt taps, going to a full wave bridge rectifier. From there, it's going to the filter cap, through the choke, and back to the other section of the filter cap. So what I want to do is fire it up, look at the voltage, we're going to load it, throw a scope on this thing, and see how clean it is. So here we go, power supply test. I have my meter looking at the filter cap as well as the oscilloscope. We have a 10K resistor at 10 watts loading the power supply. I'm expecting this is going to be a little over 400 volts, so we're going to be pulling a little more current than what that resistor can handle. So I'm not going to keep it on there very long, but I just want to see what the voltage is, see what the ripple looks like, and then I'll continue with my build. So here we go, I'm plugging her in. There's our voltage, 437 volts. Here's my ripple, that's 0.1 volts per division. So I'll pan the back, you can see our fuse holder, our speaker jacks. There's our output transformer, power supply section with the choke. And over here is the big old 6V6 Class A tube being driven by the original power transformer. If you look down here behind the old speaker grill, you see some blue high intensity type LEDs that light that up very cool. So now let's look around at the bottom. Alright, here we are bottom side, power supply section, which we already talked about. Here's my filament lines going here, and then they take off around this metal divider to the 6V6 and the 12AX7. As you can see, it's all point-to-point wired. My controls are up here, volume, treble, bass, and there is that input jack, and as you remember, I had to modify the chassis to get that in there. This here, this 1K resistor, is our biasing resistor for the 6V6, which goes to pin 8, and this is a 100 microfarad cap that's strapped across that. Okay. The reason I had to go with a 1K is because at 435 volts plate, I needed to limit that current so the 6V6 didn't go up in a puff of smoke. The wiring turned out great. I used some coax here, as you can see. Everything else is pretty much laying against the chassis. This project turned out to be a noise-free amp. So let me put it on a scope, show you how it works. So here's the initial test that I do on all my amps. It's just a noise test. So I'm looking at the noise level of the amp with no signal applied. Okay? So if you've built an amp and you turn up full blast, you sure don't want to see a signal if you're not applying a signal, right? So my scope is set up at 50 millivolts per division, and I've got the amp on, as you can see. I'm going to turn this volume up full blast, and let's watch the CRT. So here we go. So there we are, full bore, 50 millivolts per division. You wouldn't even hear that little bit of hiss on your speaker. So that's a good sign. So next, we're going to apply a signal and see what the sine wave looks like and see what kind of breakup we get off of that Class A 6V6. So now we have a signal generator in the background, which is my WaveTech. Looks like I'm at about 900 Hertz. The scope now is set up at 5 volts per division into a dummy load. It's an 8 ohm dummy load simulating a speaker. Right? So once again, let's bring up the volume, and now you can see the sine wave. Right? Now I'm going to crank it. You can see some nice breakup. Okay, now let's bring up the treble. You can see the treble is affecting that since we're at 900 Hertz. But when she's not breaking up, she's got a pristine looking sine wave. I can vary the frequency around. And this thing really looks like it's performing well. Obviously the real test is to put a speaker on it and have somebody that knows how to play demonstrate it to you. But for D-Lab's aspect of this amp is working perfectly. If you want to build one of these little Class A amps, it really doesn't have to be in this police radio type cabinet. You could put this in anything, or you could build the same circuit as an open chassis amp that you could run on your favorite external speaker. So let's cut to the schematic. As you can see, it's a very straightforward, simple schematic, and that's why this thing sounds so great. There's not a whole bunch of overkill of things you don't need. It's taking the input signal, amplifying it, and giving you a great output. Alright, so the input is your typical 12AX7 with a tone circuit just like Fender uses. So if you look up that tone circuit right there, it's like textbook Fender. Okay, then we couple through the 0.022 microfarad cap to the grid of the 6V6. The only special thing about this amp, if you look at that output transformer, that is an ultra linear type output transformer with a screen tap. Alright, those are sold by Triode Electronics. The power supply now utilized the original transformer that the old Lafayette had when it was built by Trio. Okay, but you don't have to do that. Okay, you can just get a stock transformer and put it in and build the same circuit. You don't have to go by this print. But if you find one of these old police receivers that is destined for the dump, guess what you can make it into? A very cool little Class A amp. And right here, D-Lab is giving you the information for free, so you can build it. How cool is that? Alright, so we'll do a real quick on the air test. So here's the amp. I'm going to go full volume. Nothing connected. You hear that little clang, and possibly, what could that be? Now I heard that today is National Wine Day. Is that correct?
It is.
So what did Marcia get me? A bottle of Decoy. That's like 20 bucks a bottle, I'm sure. Right? It's a little above D-Lab's budget. Right?
A special occasion.
Righto. So now, let's go ahead and hook up a guitar, because you guys are probably wondering, does the amp really work? Of course it does. Alright, there we go. It's like 3/4 volume. Beautiful, isn't it, sweetie? What about the glass? This radio's been through a lot more than a little bit of wine poured on it.
You make people nervous when you do that.
Well, there's your step-by-step procedure how to build your own cool Class A amplifier utilizing an old rusty radio. That's what I'm known for, right? Now, I would normally have a live demonstration at this time so you can hear what the amp sounds like, but I can tell you it is a screamer. At 435 volts plate, this thing had the same power as a Fender Champ. Alright, so we'll have those live demonstrations later, but for now, go out and find your radio and get building.
Yeah, well, if you want some great candle holders made out of wine bottles, come see me, Dick, from the internet. See ya.
Yeah.